All right. So in this video, we will learn how to analyze mechanisms. Okay. So let's start with this question over here. You are given a mechanism, and you are asked a question. The arrows in the mechanism above are labeled A to F. Which of the arrows represents bond breaking? Okay. So let's see which of these arrows or curved arrows or mechanistic arrows represent bond breaking. Okay, so if you look at the first arrow, it's going to be a breaking of the CO bond. So I'm going to call it BB. And then arrow B, curved arrow B, is making a bond between this oxygen and carbon. So that's a bond forming arrow, BF. And then arrow C is forming a bond between oxygen and carbon. We can see that after that we have a double bond formed in structure 4. There's a bond forming arrow. And then the arrow D is breaking the carbon chlorine bond. Now it's a bond breaking arrow, because you can see that this chlorine is removed in the next step, in this step. And then E, arrow E, shows again a bond breaking, because we are breaking the OH bond. So I'm going to call it BB. And arrow F is forming a bond between that oxygen and hydrogen. And there's a BF arrow bond forming. And that's it. So we have how many bond breaking arrows? We have 1, 2, 3 bond breaking arrows, and those are A, D, and E, A, D, and E. So that should be option C. Okay, so let's go back to the previous page. And then the correct answer must be option C. All right, let's move on to the next question. Okay, in this question, it's the same mechanism, but you are asked to determine the overall reaction for this process. Okay, so to tackle this problem, okay, I think I'm going to use a screenshot. All right, so what I would do is, there are 3 steps in this mechanism, and how do we know that? You can see that there are 1, 2, 3 arrows here, so indicating 3 steps. So I would write out the 3 steps to be on the safe side. Okay, so let's start. First of all, we have this molecule over here, chlorine. Okay, and then that reacts with water to produce this molecule. We're going to have O minus and O hydrogen. Okay, so the water molecule is added to that molecule now. Okay, now in the second step, this is step 1. Okay, in the second step, we're dealing with that molecule, which has a positive and negative charge. Here, what is happening is these lone pairs, one of the lone pairs of oxygen is going to make a double bond between that carbon and oxygen. And then at the same time, the carbon chlorine bond breaks. Okay, when that happens, you're going to get carbon oxygen double bond. And then chlorine leaves, and to this now we have still this H2O combined or attached. Okay. And you get the previous step as well. And then Cl minus would be a product of the second step as well. Maybe the Cl minus left. And then in the third step, step 3, what is going to happen is this molecule is interacting, which has a positive charge now, is interacting with a water molecule. Okay. And then that water molecule is going to act as a base to grab one of the protons from here. For the OH bond breaks. Okay. And then when that happens, you are going to get carbon group and then no H, and also you're going to end up with H3O plus now, because when the proton is grabbed by the water molecule, you're going to have an H3O plus sign. Okay, so this is what is happening in this reaction. So to find the overall reaction, what we need to do is we need to add these steps up. Okay, and when we do that, the intermediates cancel out. You can see that this is produced and consumed, so that cancels out, and this is produced and consumed in a subsequent step, so that cancels out as well. So if you add up what is on the left hand side of the arrow, you can see that I have this molecule in the reactants, and also I have 2 water molecules. 1, 2 water molecules reacting on that. And on the right hand side of the arrow, I have this molecule as a product, and also I have Cl minus and an H3O plus. Right, so that should be our balanced chemical reaction. Just to make sure, we can count let's say the hydrogens if we want to. So we have 4 hydrogens without discounting what in the carbon hydrogen bonds. Okay, so on the product side, and you can see that from the 2 water molecules, so I have 4 hydrogens as well, so it is balanced out. And then again, we have 1, 2, 3 oxygen atoms on the reactant side, and 3 oxygen atoms on the product side as well. So that's the balanced chemical equation. Now, the other thing we want to do is, now you can see that none of these options are showing the line structures. So we want to be able to convert this to Lewis structures. So in Lewis structures, Ns and Bens are carbon atoms. Okay, so first of all, before we do that, we can check that our products must have Cl minus and H3O plus. Okay, if you look at these answers, there's only one answer that contains Cl minus, Cl minus and H3O plus in our products, and that's our option C. So that must be the correct answer. Okay, so just to make sure that we understand how to deal with the line structures. So if you think about one of the reactants here, this okay, if you think about this reactant over here, if you want to convert this to a Lewis structure, we need to replace the Ns and Bens with carbon, and the common bonding pattern of carbon is fulfilled by carbon hydrogen bonds. Carbon usually forms 4 bonds. Okay, so you only had 1 bond here, so we had to add 3 carbon hydrogen bonds, and the carbon in this at the middle has 2 bonds now, so we need 2 carbon hydrogen bonds. This carbon has already 4 bonds, so that is fine as it is, right? And if we count them, we have 3 carbons, okay? And then if we count the hydrogens now, we have 5 hydrogens. 1, 2, 3, 4, 5 hydrogens, and one Cl atom, and then 1 oxygen. And you can see that that is what we have as a reactant over here. Okay, and we can do the same thing for the product side as well. What I'm going to do is I'm going to take this molecule now, and I'm going to write the Lewis structure for that. Okay, so what we need to do is we need to replace the ends and bends with carbon atoms. There are 3 of them, and then replace have carbon hydrogen bonds to make sure that carbon has 4 bonds around it. Okay, and then to make it a perfect Lewis structure, you have to add the lone pairs as well. But anyway, is not relevant for for this question at least. To this question at least. So let's avoid that. Now let's count the carbons. Again, we have 3 carbons. In hydrogens wise, we have 5 plus 1, 6 hydrogens, and then there's no chlorine, and then we have 2 oxygen atoms. That's what we have in this option C as one of our products. Okay, so it makes sure, it shows us that our correct answer must be option C. Okay, so the correct answer, let's move on to go back to the previous slide to see the correct answer. So the correct answer is option C. Okay, so let's do another one. Okay. Okay. Now, same mechanism. How many intermediates are present in this process? Okay. Now, what I have to do is go back to what we did before, if I can. Okay. Really not, but that is okay. It's okay to do this again. So again, whenever we have a question like this, okay, I suggest that we write out each step, okay, so that we can determine the intermediates, reactants, and products and catalysts very easily. Okay, so again, if we draw the steps here again, okay, so let's say this step 1, you have this molecule reacting with H2O, okay, and then you can see that this H2O is acting as a nucleophile, okay, and attacking this partially positive carbon over here. As a result of that, carbon oxygen bond is going to break like that, and then at the end of the day, we are going to get oxygen, and then it's there, and then also H2O is going to be added to it. And this oxygen is going to have a negative charge, and the H2O part is going to have a positive charge. That's our first step. And then in step 2, we see that this molecule over here, okay, is not reacting with anything else, but what is going to happen here is one of the lone pairs is used to make a carbon oxygen double bond, and then the carbon chlorine bond breaks, and as a result of that, you are going to get it's the same carbon oxygen double bond, and also chlorine is going to be removed. That's our second step. In step 2, we'll be using this molecule over here, okay, which is going to react with water. Okay, so in this step, water is going to act as a base to grab this proton, and therefore the OH bond breaks towards oxygen, and as a result of that, we are going to get OH, okay, plus H3O plus. Okay, now we see that this guy over here is produced in the first step and consumed in the second step. So it is an intermediate. So is this. This is produced in the second step and consumed in the third step. So that's an intermediate as well. So we can see that we have two intermediates in this process. So the correct answer must be that. Okay, we can check that. So the correct answer is 2. Okay. Now let's move on to the next question. What is the role of water in this reaction? Okay, so we saw that water ended up on the reactant side. Okay, since water ended up on the reactant side, water must be a reactant. Okay, that is it. So let me see if I can show it to you one more time without drawing. Okay, so it doesn't matter. Okay, so water is a reactant here because it is on the left-hand side of the arrow, and for the role of water is reactant. Okay, let's do another one. And then in this case, they're asking how many steps in this reaction are acid-base reactions. And the characteristic of the acid-base reaction is there's a proton transfer. Hydrogen with positive charge is transferred from one molecule, which is called the acid, to another molecule we call as a base. Okay, so the only time we see an acid proton transfer is in the third step. Okay, you can see that we are so the water molecule in the third step is grabbing a proton. Okay, so here in the third step, you can see this water molecule is grabbing a proton, and then this proton is transferred from molecule 4 to molecule 5. Therefore, we're going to end up with H3O plus after water accepting that proton. So that's the only step that we can characterize as an acid-base step. So it's just going to be only one. The correct answer must be 1. Let's do one more. Identify all the nucleophiles in this reaction. Okay. So again, nucleophiles are electron-rich molecules with electron-rich centers that attacks electrophiles that has electron deficient centers. Okay, so you can see in the first step, the water molecule here is using its electrons on oxygen to attack the electron deficient carbon here. Okay, so electron deficient carbon, because we know that because carbon should have a partial positive charge, and then oxygen is partially negative, and then therefore this water molecule over here is acting as a nucleophile. And in the second step, there are no electrophile reacting with the nucleophile, okay, because there's only one molecule, and we have the bond breaking and bond forming within the molecule. Therefore, it is not considered as a nucleophile or electrophile or nucleophile. Now, when you go from second step to third step, okay, again, we know that this water molecule over here is using its electrons to grab a proton, which is going to have a partial positive charge. Okay, then again, because this water molecule, the oxygen of water molecule is knowing the positively charged centers, it's going to be considered as a nucleophile. Okay, so there are two nucleophiles. That should be 2 and 5. So the answer must be option A, which is over here. Okay, so let's check that. The correct answer to that is option 1. Okay, so that's how we analyze a mechanism. Right? We can use a mechanism. I mean, you can be given a mechanism and asked to find the bond breaking and bond forming errors, and also you can ask to find the intermediates, and you can be asked to find the role of some substances there, some molecules there. Some of them act as intermediates, some of them are reactants, some of them are catalysts, and some of them are products. And then we can talk about which ones are acting as nucleophiles and which ones are acting as electrophiles in a given reaction. Okay, so I hope this helped. I'll see you guys later in class. Bye, everybody.